So what I'd like to do now is I'd like to continue on with our discussion about Android components. If you recall, last time we talked about the activity component, which provides support for user-facing operations. And you've got a little bit of experience with that with the map app application assignment. And now what we're going to do is we're going to talk about services, which are used to run in the background, and they're typically implemented to perform long-running operations and/or operations that access remote services, which may be long-running. So we're going to talk about services. There's going to be a whole pile of stuff on services we'll talk about later. This is just the introduction to the whole thing. OK, so let's start talking about a service. So activities interact with the user. You've got experience with this now. You're able to prompt the user for input with a text view. You get the user input with an edit text. You're able to do various things, and then you're able to display the results back to the user with text views or image views or things like that. Conversely, services don't interact with the user. You can take a look at this link to find out more about what services do in fact do. Instead, activities, although you can also have other things besides activities, but most commonly activities use services to perform these long duration operations, things that would otherwise block the user interface. And they're also often used to do things that go across the network, which typically take a variable amount of time or a potentially long amount of time to run. For example, we might have an implementation of our image downloading application that could use a service in order to be able to offload the work of blocking in the background, downloading a requested image, doing something to it, processing it, storing it, whatever, and then finally returning something back to the activity that the activity could use to display in the user interface thread of control. And in fact, you guys will get some experience doing this later in the course, although not right this second. And you can take a look if you want to see an example of an activity and a service that do this downloading operation. You can take a look at this link where there's a sample application that uses some interesting Android features to do all this. A lot of stuff in Android uses services. So there's an email service for doing things to talk to, say, Microsoft Exchange or Google Mail. There's contacts. There's calendar services that are used to talk to Exchange calendars and contacts or Gmail calendars and contacts. There's stuff that deals with the phone. There's something that interacts with back-end, I think they're called MMSCs, Multimedia Message Service Centers, which are used to upload and download messages in either SMS format or MMS format. There's a service that's used to play music. It's written in C and C++ that you can use to stream audio. There's also probably video services that are there as well, sort of AV services that you have. So those things are all done as services, and they run in the background. So it's a very common thing you'll find on Android. Typically, activities launch services. And we'll see there's a couple different ways to do it we'll look at in just a minute. So you'll typically have an application that has an activity in it, and usually it'll start the service on demand. There are some services that are always running that are called system services, but we're not going to program them. We're going to be focusing on programming application level services as opposed to system services. So one reason to have a service is that even if the activity was to change, if you were to navigate away from one activity to another activity, the service can still be in the background doing its thing. Whereas normally, as you recall, even from something as simple as the Maps application we did, if you navigate away from the activity that you're currently in, that activity is suspended, right? It's paused, it's stopped, maybe even destroyed, depending on what you're doing. And so as a result, that activity will stop doing its thing. And anything that's going on inside the activity will also stop doing its thing. So we want to be able to have a way of having things continue even if the user navigates away. Can anybody think of a real obvious example of something that continues to work or can be configured to continue to work even if you're not actively using it in the foreground? An alarm, yeah, that would be one thing. Although they're typically handled in a slightly different way, but that is a good example of something that's handled in the background. Music player, exactly. So the music, you start playing your music, and then you can continue to browse the internet. You can continue to do a whole bunch of other things, and the music is still playing in the background. That's why they implement that as a service, because you don't want to have it pegged to the activity. Now, one of the consequences of this is inside of a service, and we'll talk more in a second about what goes on inside of a service, you don't want the service to try to access the user interface directly. So that means all the things you can do to, set text views and write to text views and so on, all that kind of stuff, you can't do in a service. And if you try to do it, hopefully bad things will happen, right? Hopefully you'll get an exception because you're not allowed to do that in that particular context. The way that you make this work, the way that you have services communicate back to activities where the displays actually take place, is to use some kind of communication mechanism. And depending on whether you're running in a separate process or not, which we'll talk about how you do that later, then you might have inter-process communication communicate from the service back to the activity. Or if they happen to be co-located in the same process, you may pass a message or some other means of getting communication to go back. We'll talk shortly about how you configure things to run in separate processes or not. It may come as a surprise to you that by default, a service actually runs in the main thread of control, in the user interface thread, which seems a little odd. But that's what happens out of the box. There's some ways to override that if you want. OK, how do we implement a service? Well, again, there's a bunch of different steps. So the typical thing you do, although not always do this, is you could extend the service base class or superclass. So one thing you can do is you can say, my download service or whatever extends service. We'll see later that there's other ways of doing things that involve extending predefined service helper classes like the intent service, but we'll talk about that later. So a common way is to extend the extend service, and then you go ahead and you override several of the so-called lifecycle methods or lifecycle hook methods. A hook method is just something that's called back by a framework. There's basically 5 of them. There's a few more I didn't list, but these are some of the most common ones. OnCreate, which is very much like OnCreate that's called when an activity starts up. It's a way to initialize things. It's kind of a virtual constructor. OnStart, which is called when an intent is passed to the service. OnBind, which we'll see later is used when you have a so-called bound service. And then OnUnbind, and then OnDestroy. There's a couple other methods here, like OnRebind, we're not going to talk about. But these are the main methods. And we'll talk later about how you override them and show lots and lots of examples. Sometimes you can do all the work in the service in those hook methods, those lifecycle methods. More commonly, however, you define other methods that actually do the business logic of the service. And sometimes these are called back by those hook methods to do their job, or called by those hook methods. So we might have a helper method called makeIntent. We might have some kind of class that is used to extend handler. There's a bunch of different kinds of things you'll do, and we'll go into that in much more detail later. Oftentimes, these other methods actually implement the concurrency and communication behaviors of a service. That's a common thing to do, have that done in these sort of helper methods, these business logic methods that you've got. And then the final thing you need to do is you need to actually, if you want the service to be externally visible to other applications, you need to list the service in a manifest file, the Android manifest file, just like you did with activities, although there's a few subtle differences that we'll see later. So here's an example where we're going to make the service be advertised in the application that we had from before. Now, I'll come back and talk more about this because there's some other important things that you need to be aware of when you configure services in a manifest file, but this is at least one thing. A very common mistake when you're dealing with services is to implement the service and then forget to describe it in the manifest file, and then when you go to run your application, it doesn't work. And the reason it doesn't work is because it can't find the service because it wasn't advertised. So that's a common bug you'll probably run across at some point. All right, that was a quick overview of services. Let's talk a bit more about types of services. Everybody know where this is from, of course, right? The matrix, right? The blue pill or the red pill. Somebody asked Bill Gates that question one time, blue pill or red pill? I forget what he said, but actually I don't even remember what the difference is, but there was a difference. So the two types of services, one is called a started service, and the other is called a bound service. So let's start with the started services. So this is the started service, and these services are intended to be launched on demand, and they will continue to run until they are explicitly shut down, and we'll talk about how they can be shut down in much more detail later. But the key point is that They're usually launched and they run to do sort of one thing, and after they do their one thing, they typically go away. They don't have to go away, but they typically go away. So they're called a started service. And you start them by having somebody, typically an activity, invoke start service, passing in an intent that identifies a particular service instance, much like you do with start activities. So start activities used to start activities, no surprise there. Start service is used to start services. We'll see that there's other ways of getting services to start in a second. You could also pass parameters as extras to the intent that's used to start the service. We talked about this with activities as well. It's not uncommon to pass parameters to pass in extras to intents when you launch an activity. It's more common to pass them when you start a service, and we'll talk about that later. We'll see some examples. A started service typically just performs one operation. It could do more, but it's typically just going to do one thing. So once it's up and running, the onCreate method gets called. When it's first started, the onStart command is called. It gets the intent that's passed in, and after that, it's running and doing stuff. Often, although not always, a started service doesn't directly return a result to the caller. So you might start something off, and it goes off, and it kind of runs in the background and does its thing. And when it's finished, it might do various things, but it doesn't necessarily have to tell the activity that launched it anything about what it was doing. You can almost think about start service as kind of like forking a process. If anybody here knows about Unix, forking a process is kind of like starting a service. Not exactly, but it's kind of along the same idea. So that it doesn't necessarily have a reply. And a started service typically needs to shut itself down when it's finished. And the most common way of doing that is to call stop service on yourself. And we'll see later when we get more into this that there's a bunch of subtleties involved in how you stop a service and so on and so forth. It's also possible for another application to stop a service, but that's not the common thing to do. Most commonly, a service stops itself when it's finished. If it doesn't stop itself, it'll keep running until somebody else stops it. So that's the most common thing to do, is for it to stop itself. And when it stops itself, its onDestroy method gets called, which acts kind of like a virtual destructor, which will go ahead and clean everything up. All right, so that's a started service. You'll get a chance to play around with started services. We'll have an application where you write an assignment where you'll write a started service and so on. The second type of service is called a bound service. And a bound service is quite a lot more interesting. Unlike started services, which are launched by start service, bound services are launched by bind service. And bind service is a little bit different. Actually, it's quite a bit different than a started service. The main reason why it's quite a bit different is it actually kicks off a handshake between the client that invoked bound service and the service that's being started, even though it's bound. And so what happens is there's typically a onCreate method is called, but there's also what's called an onBind call. And onBind is used to return back to the client application some kind of channel for communication that the client will then henceforth use to engage in two-way conversations with the service. So unlike a started service where it's typically, you send it off to do something and it may or may not reply, a bound service very commonly has a conversation take place between the client and the service. And we'll talk in a second how that conversation works. But the key point is that there's a conversation. And there's also a handshake that takes place between the service and the client in order to establish the means by which this conversation can occur. And it's used by passing around these channels, which turn out to be something called I-binders, which we'll talk about later. You don't have to know the details of that at this point. The interesting thing about a bound service is that it's automatically destroyed when all the clients that have bound to it go away. So it reference counts the number of clients that are connected to it, and when the last client goes away and unbinds, then Android's runtime infrastructure, its activity manager service, will automatically shut down the bound service. Now, there's also some interesting hybrid models where you can have a service that's both bound and started, which is pretty crazy, and we won't talk about right now, but we'll talk about it later. I think the music player is actually both a bound and started service, and I'll explain why when we get to that point in the class. Now, some interesting things about this, which I didn't really talk about here, but we could have, is that there's a lot of interesting mechanisms used to communicate between a client and a bound service. And the most common way to do it is with something called the Android Interface Definition Language, AIDL, and the binder framework. And so what this basically gives you is a way to do remote method calls between the client and the service that in fact can transcend process boundaries in the Linux kernel. And we'll talk a lot more about that. A lot of really, really cool stuff lurking in that space. Okay. The next part here, I guess this is kind of I would just give you a foreshadowing of what I'm about to talk here. Started and bound services can either run in the same process as their clients. So you can have, whoops, that's a mistake. This should say just say main process, because that's what that is. So they can either run in the same process, or the service can run in a separate process. So we'll talk about why you would want to do this, and we'll also talk about how you would do this. So let's talk first about how you do it, and then we'll talk about why you do it. So there's a couple different ways you can have things work. One thing you can do, if you want to have things in different threads, even if they end up being in the same process, is you can end up extending from the intent service, which is a very cool implementation of the command processor pattern that we'll cover later. You could manually spawn a Java thread. You could use a thread in the executor service, thread pool, blah, blah. There's a bunch of different ways you can do it. That's one way. You can explicitly program things to be multi-threaded. Another way you can do things is to use a configuration setting in the Android manifest file. So you can actually put a directive in here, an attribute that says, I want this service to run in its own process, and here's what I want the process to be called. So I can say I want to have a process, and I want to call it my process, just to give it a very unimaginative name. So that will actually direct the Android Activity Manager service, which is a system service, to start this service in its own process. So you don't have to do anything else programmatically other than modify that file. Yes, Robbie?
Can a service itself be multi-threaded?
Yes, absolutely. In fact, that's very common. Very common to have the service itself be multi-threaded. Yeah, so whether or not a service runs in a separate process or not, it's usually the case you want to multi-thread the service. So we'll talk more about those issues as we get further into it. All right, so a couple questions. So those are the mechanisms. Now, why would you ever want to have your service run in a separate process? Can anybody think of a motivation for doing that? Robbie?
Well, if it's in a separate process, then if your main process gets shut down, it can still run.
Great. So the basic observation here is that if you run the service in a separate process, its life cycle is no longer bound to the application activity that started it. And that would be particularly useful if you want to be able to share that service with other activities that might come along later. So if you want to have a service that's doing something on behalf of a bunch of different applications or a bunch of different activities, having it run in a separate process makes it easier to share that service, or makes it possible to share that service with multiple activities or multiple applications. So that's one reason. That's a good answer. Other thoughts? Yes?
Maybe if you don't want to interrupt or distract the main process, it's more important.
Right. So you can also set, the other observation is having to do with priorities. So you can give the service a higher process priority. You could also play around with thread priorities and get much the same effect. But take your idea one step further. If something goes wrong with the activity, the service would be unaffected. If for some reason your activity just goes berserk and it causes the application to shut down, your service could be protected. So running things in separate processes help to protect them from reliability or security issues. So those are some other interesting things. Okay. As we said, services that are shared by applications have to run in separate processes. So if you have multiple applications with different activities or different versions of the same activity and so on, they have to run in separate processes. And there's a nice tutorial here by this guy Lars Vogela, who has a whole bunch of cool tutorials on Android, and he has one about services that you might want to take a look at. Now, once you start to have your activities running in a different process than your services, you've got to find a way to communicate with them. And there's a bunch of different ways to do this. And the fancy name is inter-process communication, or IPC. Keep in mind that for all the IPC mechanisms we're about to talk about, the client and server processes are on the same device. There's a whole other pile of inter-process communication mechanisms we'll talk about later in the course where the client and server processes are on different computers. Some might be on your phone, some might be out in the cloud somewhere. And you're typically using sockets and TCP/IP and internet protocols in that case. This is not that scenario, though. This is where their processes are co-located on the same device. So here's a bunch of different kinds of inter-process communication mechanisms that can be used to communicate between these things. So you can send intents. We'll talk about intents probably next time. You can use things called messengers and handlers, which are a form of message passing. For those of you who are into patterns, by the way, which we'll cover much later, intents are basically the command processor pattern. The messengers and handlers are the active object pattern. And then the Android interface definition language and binder framework provide us with something called the broker pattern, the proxy pattern. And the binder framework, as we'll see, is what is the magic that all these things use under the hood in order to enable efficient inter-process communication. And as I've been alluding to throughout this discussion, there's a whole pile of patterns, gang of four patterns, POSA patterns, and so on that underlie this stuff. And as we get further along, we'll go through that. Some of the patterns you might be familiar with from CS251. There's a lot more patterns that are not covered in the Gang of Four book that really are what Android uses for concurrency and communication. So we'll cover those later. Here's a list of some of them. I won't go through them now, but there's a lot of cool stuff here.